shower here. So I ate very fast right before this, but you guys get to enjoy the hour listening to me drone on. So I appreciate taking the time today. A little bit about me before I jump in, and then I'll talk a little bit about my company as well that I work for. I've been in the industry in Chicago for around 10 years now. I originally started working for the Hill Group in the energy division in the commissioning side. Around 5-6 years ago, that group merged with the test and balance group at our company, which was Aero Test and Balance, and we became Aero Building Solutions. So really, it's just a lot of us just to do the consulting services, and then there's our tab side as well. So a lot of assistance with construction, test and balance, which you're probably most familiar with Aero. And then we do commissioning, retro commissioning, and then monitoring based. A lot of energy audits, work like that. MBCx for us started around 2015 with very few projects, and that was also around the same time that the ComEd utility program rolled out. That really drove the industry towards this, and you see a lot of these software companies kind of popping up, a lot of people getting involved with it. It's really where the industry is kind of going at this point. And it's great for energy and analysis that way, but there's also other reasons to do maybe some monitoring-based commissioning that I'll talk about a little bit later today. A little bit more about me. I've been involved with MCAA, BOMA, some other organizations, but obviously ASHRAE is my favorite. I've been doing that since 2013. And there is another group that's kind of formed. It was right before COVID. It's called BIG Chicago, or Big Chi. It's the Building Intelligence Group, and it specifically relates to a lot of people doing intelligent buildings, monitoring-based commissioning, and any of that IoT type work you'll see. So that originally started in Minnesota. The Chicago chapter was, again, right before COVID. It got some traction, and there's kind of that lull period. And then I also want to just state that I actually gave a very similar presentation that you will be viewing and hearing me speak about today back in 2020. It was literally the day before Chicago shut down. And that was the in-person ASHRAE conference back in 2020. So if you attended that one, this might be a little bit similar. But again, I appreciate you jumping on again. So enough about me, I guess. Let's just dive in. I'm going to leave a lot of time for questions and answers at the end. The presentation itself should be about 30 to 40 minutes. And then typically there's a lot of questions. So I won't power through. If something needs to be repeated, just type it in and I can go back to it at the end as well. Just let me know. All right, so outline, I'll go over basically monitoring-based commissioning and analytics itself, kind of go through how to set up a job and like typical timeline. We'll go through a lot of hurdles and issues we see on sites, and then just dive into some examples. And then, like I said, Q&A at the end. And I'm happy again to touch back on anything if it comes up. So basically, MBCx, you're using software and you're using some programming and maybe a little bit of engineering mind to basically analyze data and look for things that you wouldn't get on a typical BAS. It's a process, and you see there alarm versus analytics, and I'll go into that a little bit more, but essentially we're applying a lot of different rules and things that we're looking at that give us more insight into a building than just, oh, my space temperature is too high. So that's an alarm you get at your BAS any day. You get temperature alarms. Building engineers see it all the time, but why do we have that temperature alarm? So like an analytic, for example, let's take just a typical space that's served by a VAV box, and let's say that it's too hot. Building engineer gets that. They might go into the screen, override a bunch of stuff, try to get to work, whatever it may be. But on the analytics side, what we're going to look at is we'll write a bunch of different code into that, where we're looking at all the different points on that VAV box and why is that temperature high? Well, let's say the damper's at 100%. But our airflow is reading less than the set point. So we can make an assumption that the reason the temperature is high is we're not getting air, the proper airflow to that box to actually cool. So we would flag that instead. This, brings that to the attention of the building engineer. They can focus in on something more specific than just, oh, it's hot in the space. They know it's a damper problem. They can look at the damper, the actuator, whatever it may be on that box, and get that fixed. Another example, let's say we have an air handling unit with a discharge temperature that's below set point. A lot of things can cause that. But let's say we wrote an analytic and we're looking at a chilled water valve and it's at 0% open, but our THE is still less than set point. It looks at the preheat temperature, and that's pegged at 100%. And we still have a discharge air temperature less than a preheat temperature. What we see here is we probably have a leaking chill water valve, or an actuator that slipped off. Something's happened where that valve is thinks it's shut, but our temperature is still leaking through and getting cold. So there's other things that the unit does to counteract that. What a building engineer might think is if we didn't have an analytic on there, let's say that the preheat valve wasn't opening up fully, it was just our discharge was less and the chill water valve was 0. They might just override that chill water valve to 100% without it actually doing anything, and then you don't know why that temperature is lower than it is showing. This really helps pinpoint and troubleshoot a little bit further. So kind of some of the things you can do with MBCx and analytics, and we'll dive into some examples of these as well. Fault detection and diagnostics. So is it operating as it's intended? There's a couple examples I talked about right before. Performance analysis and scoring. So this is how well a piece of equipment is operating, and that could be over time, or that could also be compared to other similar pieces of equipment. You'll see an example later. Let's just talk about VAV boxes again. I want to know how well everything's controlling the space temperature. We can look at that from a time of day standpoint. We can look at that from one box to the next, and we can figure out which ones are our best performing pieces of equipment, which ones are our worst performing pieces of equipment. Maybe there's something to do with sun load or something else that's an external factor to that space that's causing a different time of day to be worse. So we can really score and analyze all of these large, unitary pieces of equipment. There's a lot of them, and do it much, much quicker. Operational tuning. So how can I make something better? Again, this is going to be kind of energy savings type measures. It's going to be other control programming changes, or maybe an operational failure, which kind of we talk about later, like a slip damper or a valve failed. Predictive maintenance. This is one. It's again, you have typical maintenance schedules, but is there something we can identify earlier, or do we need to delay maintenance on a piece of equipment? I'll use chillers a lot for an example on this. So, your typical BAS maybe only shows temperatures and operating output, and are you getting to your, chill water set point that you want? But there's a lot more going on with that machine that might be on the BACnet side that they don't see if it's actually at the BAS itself. So, an example of that could be approach temperature. We could look at the refrigerant versus the leaving water temperature and how different that is. Is it changing over time? And we could set up an analytic that looks at when that approach temperature gets too high. It indicates that maybe we have some fouled or contaminated tubes, and we know that we're ready for maintenance now on this machine prior to it going down or having an issue and then not being able to maintain temperature. Or conversely, you have a quarterly maintenance contract and you're always doing your maintenance, and we're a contracting firm, but maybe there's some on here as well. Obviously, you don't want to hear about delaying maintenance or not performing some work that you're supposed to get paid to do, but rather than have a failure or doing maintenance more than it's needed, you could look at something like that and make the call that, yeah, we can push this off a month or two. This machine hasn't run as much as we anticipated, or it's not fouling up, and we can wait. And the last is failure forensics. And I mean, you could do some of this with the BAS if you have trend data set up, but it could be looking at a lot of past historical data or other things and alarms that came through and determining why something may have failed. So maybe we got really high static pressure in a ductwork at some point, which caused the unit to trip off, but it was so instantaneous, maybe an analytic flags that, or we got a high space temperature somewhere in a comm ed room or an electrical room, and that caused a failure there. And then we saw the exhaust fan is down or offline or something like that. So it's looking back on all that data that we have. Some parts where you can plug in sort of MBCx is, the design side of things. So, a building gets drawn and engineered and constructed, but, there's a amount of energy used is kind of, calculated, maybe lead certification well, something else. And the owner says, we're not saving what we thought we would. Now commissioning, the typical process, we test to make sure what was installed works the way it should, but it's really just a snapshot in time. It's manipulating maybe a lot of parameters and set points to make sure that control sequences and equipment works. But MBCx will look at this for a long time, and it'll flag things. And it can also verify. It's similar to measurement and verification, which I believe will actually be a later slide, but you're essentially just looking at what was designed, what was installed, and is it operating as we intended over the entire lifespan of a building. From the building operation, aspect inside of things, I kind of talk about this again, but reactive versus predictive. So trying to catch stuff that fails or before it becomes an issue. Building engineers get a lot of calls every day about being hot, being cold, someone in a space. But they typically just throw band-aids on it because they have a lot of stuff to deal with. It's tough to deal with a high rise. Let's take a high rise that has hundreds of people in there every day with different needs in different areas served by different equipment. They're working on, let's say, a bigger problem somewhere else, and you get a hot call, and you say, just override the damper to 100%, let it cool, and that takes care of it temporarily. But then you start having some issues down the road. The idea is that with monitoring-based commissioning software, we're going to flag those overrides or flag some other problem or failure before you get that next complaint that now they're too cold. And really, again, it gives us increased transparency into a building system. So we're looking at everything beyond just an alarm level that just says, again, my space is warm, my space is cold. Why is that the case? M&V, again, kind of talked about that before, but to do an actual M&V, you either need a ton of utility data, a ton of data logging, a lot of loggers maybe installed just to get all that information off. And especially if you're looking at like an air handler, if you have a lot of things on, on an electrical panel, you might have a high level data, but not really, really pinpointed in. Again, having all this information really from a building is just another way to really gather all of that. And you can really dive in and say, okay, yes, this is you performing exactly how it's supposed to. It's using the energy we expect. And vice versa versus high level, yeah, we're getting there, but some things are overperforming, underperforming, whatever it may be. So energy efficiency. So I'm sure a lot of people on this call kind of have done a retro commissioning or at least familiar with the retro commissioning program. So again, it's a great offering. RCX is awesome. MBCx just kind of takes it a step further. So again, some of the reasons you'd use RCX maybe over MBCx is if you have a really old BAS or no BAS, there's no reason not to do any energy study, but you can go in there and still pull some trend data. Maybe if they don't have a BAS at all, you're just looking at equipment and how things operate, looking at thermostats. But it's also just a quick window of how the building is at that point in time. It's maybe a 2-week, 3-week period, maybe a month. It's one season or one time of the year. You really don't have as much information as you would on a monitoring job. It doesn't mean monitoring works everywhere. You do need a fast network. A newer BAS, less than 10 years is ideal. When I first started doing this presentation, there was a lot of automation systems that wouldn't even work. Technology's come a long way since really this has become something in our industry. The downside to a retro versus an MBCx is, you have a lot of assumptions in that short period of time. Whereas, with monitoring, you're looking at something through, the course forever, ideally, or at least a year. You get to change in seasons, you get change in operation because of that. And you really have unlimited data and information on what you need. So this chart here just kind of shows that. So if, you follow the lines up here, we have business as usual. So you just let a building operate over time, with overrides or failures or issues. Things start to drift, you're going to be using more energy in a facility. Let's say we go through a recommissioning or an RCX, a retro commissioning. You can see that blue, the dark blue, you get some savings now, but then again, over time, things start to drift. With monitoring, the idea is because we know what we fixed or made energy savings to, we can track that over time, and now you're persisting with that change. And that's that gray line there. So we're keeping the energy savings we came up with. And then in an ideal world, we find even more energy savings and opportunities. And then now we're actually saving more energy than expected as time goes on. So setting up a job and how does this work? Pretty much you have this is your very basic looking building automation network. And I'm not an IT whiz, I'm not a control whiz, but I know enough to be dangerous, I guess. But what most people see when they go into a site is the BAS workstation, which is at the top. That's essentially the computer that's sitting on site that shows our pretty graphics and our temperatures, our pressures, our equipment, whatever we want to see. What that really is pulling in is all the information from these programmable logic controllers, which are field level panels a lot of times. It could be also just a controller on an actual piece of equipment, but we have those in blue at the bottom. So an MBCx device, it could be an actual piece of hardware. It could be software that you install on this network at the BAS workstation itself. But basically all we're doing is we're plugging this in on the same network so that we can sit there on the BACnet side and really just expose all this equipment and points for us to take a look at. It'd be no different than really setting up trends on your workstation itself, except that might bog down the actual network itself, whereas this device is kind of working as if it was its own controller on the site. Its job is just to sniff out all that data, and then we're going to magically push it up to the cloud. And then from here, we pull down our data, we work with our analytics, we do what we can do. Kind of a list here, and if there's any control people on here, hopefully you see your company. But these are all really compatible systems that we've seen. You know, again, there's a ton on here, but what you're really looking for is a newer BAS that's capable of handling network traffic. It needs to be BACnet open protocol, which is big. As this is an ASHRAE presentation, I will state that there is a ASHRAE BACnet standard 135. And that one basically deals with these BACnet type networks and how systems should be set up on the control side so that point names and values, et cetera, are all standardized and you know, useful from building to building. So obviously, you know, there's a lot of different companies out there and control system types out there, and you know, they're a little bit proprietary sometimes, but on the BACnet side, everything should be set up a certain way and named, points named and standardized so that it's usable, so that anyone can come in here and take a look at it. Does that always happen? No, but that is ideal. Some people too might be familiar, before the ASHRAE standard was really came out, was the Project Haystack. There's a website and you can reference, and the idea behind that was, again, looking at all kinds of different types of point names and nomenclatures and getting that standardized. For example, like if we have a space temperature, there's a million different ways that could be you know, denoted. It could be ZNT for zone temp, it could be spelled out, it could be room temp, RMT, it could be space temp, ST. It's really just getting all that naming convention down and standardized. So getting the device out there, you got to work with the IT department probably 90% of the time. Obviously, security is a big deal. Most people might remember, I've probably used this example in presentations in the past, but there was a large retail company that got hacked 1 year through the HVAC system, and a lot of credit card information and personal data was stolen in that regard. So IT is a big deal. You're coming in, you're throwing a device out on a network. Obviously, there's a liability with that. You don't want it to get hacked and exposed. A lot of the devices, and at least softwares and the way these things are set up now, it's a lot of outbound traffic. The easier way I've been told to explain it is we get them all the time, but phone calls about your car warranty sometimes come in as unknown numbers. You don't know what that number is. You can't call it back. But the only way they can get in contact with you is if you answer that phone. So that's kind of how these devices work. It will talk out to the cloud. The cloud can never talk to it unless it talks to the cloud first. That's that outbound only traffic. That's kind of how we get from the data from the building out to where we can see it as securely as possible. So working with that IT, what you need is, you know, gateway, your IP address, any other DNS information, anything with that network, so that we can sit on that BACnet side. And typically that network address, IP address and everything will share with the BAS itself that's out there on site. You're going to deploy your software, your device, set it up that way. We start to set up trends and all that information gathering. And then now we start to build and customize analytics. So it kind of goes back to that point mapping. If I write an analytics for a VAV box at one building, a lot of times those should be very similar at every building I'm in. So having that point mapping and that similarity makes it a lot easier to apply an analytic from one place to another. Not that every building is the same, not that every piece of equipment is the same. Some air handlers are different than others, but we try to standardize as much as we can to make those analytics work. And then you're going to come back and you run your analytics on a building, let's say, and you come up with a bunch of ideas, a bunch of things that are wrong, whether it be maintenance, energy related, improper operation. And then you're give it to your customer, they're going to tell you, oh yeah, this is all great, and this is the dumbest thing I've ever seen. And the things that are dumb, you want to refine your analytics and make sure that they're better and they apply to that building that you're in. And it's really just a process that you repeat over and over and over again. So again, similar to RCX here, we did one thing here. You're looking at things, you're making recommendations, but now we're going to just continue this process over and over and over and over again. Seasons change, things fail at different times, whatever it may be. But you're constantly monitoring this building and looking for improvements. And some of the hurdles that you run into, and I've probably alluded to some of these already, but your BACnet system not being proprietary is going to be a huge problem. You won't be able to expose basically and see those points. Having a local network, so no access out to the cloud. Now there's ways around this. You know, you could put like a cradle point out there or a router, similar like having a cell signal basically that can get that network traffic out. Missing equipment from a network, so you know some stuff might be local and not tied into the BAS, like unit heaters. A lot of time that's the case, or other equipment. IT issues, that's usually the biggest hurdle. What we see, you know, is again some places are tougher than others. You know, a standard office building might be much different than a hospital. Network speed and quality issues. This one's kind of out of your control, but you know, older buildings have slower networks potentially. If there's a lot of equipment and BAS equipment out there, that's again, it has to talk to everything, so that's going to be slower. Data security, I kind of lumped it in with IT issues, but obviously that is yes a concern. Network device ID, I have an example of that later, but if BACnet's not set up properly, you might see some issues with identifying what equipment's actually out there on a BAS network. And then inconsistent point names. I'll have a bunch of examples of that as well, but really not having something standardized, it can lead to a lot of problems. And I mean that not only with naming convention, but also if we have two fan powered boxes and one has electric reheat and one doesn't, you know, those aren't the same piece of equipment. So now they have to have two different, you know, analytics or profiles put on them. But let's say that the fan for one box is analog input 1. We'll just make that up. But the fan for the other one is analog input 2. If I apply the same profile to both of those and try to run the same analytics, but the point names don't line up, you could end up with issues. So just kind of an example of that device ID conflict. So this is kind of how our software looks at it. So when we're out there scanning a network, you get a list of the BACnet ID, which is that far right column. And then you get the BACnet name itself, which is that first column. And then you get the device model and type. So here you'll see there's a couple issues with conflicts here. So two pieces of equipment on that network share the same BACnet device ID. A lot of times, like if we buy a VFD or put something on a site, it has a pre-programmed BACnet ID number. And if that doesn't get adjusted, they could share with hundreds of things. What this does is when you're on the BACnet side, you scan that and two things have the same name. It either finds both and you get a blank, they don't know which one's which, or it only finds one of them. But every time it reaches out to that network and looks for that ID number, one or the other piece of equipment could respond. So if one of them is a VFD and one of them is an air handler, they're vastly different analog outputs and inputs for those. You could be getting a lot of bad data in that case. And then on the other side here, you'll see kind of a bunch of these routers came through in this example. They have different device IDs, but then they have different names for some of it. And then these two share a name. What happens is we just don't know which piece of equipment's which. So you'd have to go back to either, you know, a control diagram or a network or something else to figure out which one's which and rename that so you know what exactly that piece of equipment is. We talked about this a little bit earlier, but inconsistent point names between equipment. So in these examples, it's just looking at different fan-powered boxes. Again, you could have different types of fan-powered boxes on each site, but overall, controllers and box-to-box should have a similar number of points. So here you'll see that we can compare some of these, we'll call them profiles, that's how we set it up, but these are the points that I like to see trended on a fan-powered box, and they share. Here's two different fan-powered boxes now. One of them has 5 more points there that the other one does not possess. And then this last one here, you'll notice that there's some additional points in one of the fan-powered boxes, and then there's 1 point in the other, but you'll notice room temps on both of these. When that occurs, you can see here that that room temperature exists for both boxes, but they have different analog values or binary values or whatever it may be. So if I gave them the same, if I try to set them up the same way and run an analytic on it, it may not be mapped properly. So for example, here, like room temp could be analog value 1, and on this one, it could be analog value 2. And if I apply stuff that's looking at analog value 1 for each box, I'm going to get analog value 2 data for some of them, and it's going to look bad. It's going to be false flags on my analytics and tell me things that aren't correct. Before I jump into corrective measures, I'm just going to kind of step back a little bit. Some other ways to use monitoring-based commissioning, besides just an energy standpoint and like verifying design and all that, is actually in the commissioning process itself. Just one good example of how this works is you can eliminate sampling. So by applying analytics to all kinds of equipment, a lot of times when we test things in the field and we're doing it, it's a lot of labor intensive and a lot of time to do that. But applying analytics, I can look at hundreds of thousands of fan-powered boxes or VAV boxes when, typically on a commissioning job, you might see 10 to 20% functionally tested and really checked out. And then you make assumptions that, if 3 fail a test, then, that percentage are probably set up incorrectly. Again, seasonal testing, we kind of talked about spot checking overnight, operation when people maybe aren't in the building. You have all this going on now where it's kind of like a set of eyes into things that you may not have seen that data or those issues or things before. So just want to touch on that real quick, but we can go into some of these examples now. Here, just a list of different things, corrective measures, improvement measures that we see in a lot of jobs, and then I'll have specific graphs and examples following this. For those of you familiar with retro commissioning, there is like a top 10 measure list, which includes like scheduling and economizer operation, duct static pressure, reset, etc. Those a lot of times are improvement measers. There's also corrective things, which would be, like a damper that slipped or something that's, out of calibration, or a valve that's leaking through or not fully closed. Cycling of equipment as well, that's a big one. We can dive into some of those examples first, and I can always come back. We can talk about any more if people have questions. So this first one here, a lot of data here, but pretty graph. You'll notice that there's a yellow line that's horizontal. That's the target kilowatt per ton for this is for a chiller. Then you'll see that blue line, which is bouncing all over the place for a while there, and a red line, which is the actual efficiency of a machine. That blue line is the condenser water temperature, the inlet. What we see here is there's a valve on the chiller that we found that had basically was kind of PID loop was off and some of the control on it was bad. It was constantly opening and closing rapidly, causing basically temperature to fluctuate really quick in this machine, which also really screwed with our efficiency. When that got dialed in, later on here, you'll see November 4th and 5th, that starts to steady out now as our temperature gets dialed in as well. So, looking at cycling of equipment, so we have all these data points here, and we see them changing rapidly. That flags in on the analytic we set up, and now we get that temperature straightened out. If you looked at it on an average, you wouldn't see this cycling. It would average out because it's high and low. It might look okay, but that's that constant change now. That's something that we would flag and see. An example of predictive maintenance. So this is looking at oil pressure in a chiller. And let's say we have a low limit that, at this certain point in time, this would flag an alarm and it's due for maintenance. So we see that oil pressure start to drop down towards that red line. It crosses over, and then you see it go to 0. That's where the machine underwent maintenance. We come back online in September. That oil pressure is now in the range we expect, and then we continue to monitor that. Let's say that this runs, at that high, like we talked about earlier, that it runs in that range well for a long time, but it's time for a quarterly PM. And they go, oh, we're going to change your oil or make the repair or look at that or whatever it may be, because they know our pressure is good. We can forego maintenance at this time or whatever it may be. So it's doing maintenance before we have a failure or a problem, but also not too frequently. This graph here is an example of chiller efficiency. So this happened in a building where they had 4 machines, and the building engineers thought they were all the same. They had the same model and serial number. But one of them, you can see the blue line here. It's a lot of dots, I know, but it's a lot more linear and a lot higher in power usage compared to the other 3. This occurred because the first machine was not retrofitted with a variable speed drive, while the other 3 had that. But normal rotation through machines, they just looked at run hours, and 2, 3, 4, and 1 all shared time. That's just how it operated. So a lot of efficiency and energy savings were left on the table here, but we were able to look at these chillers over an entire operating season to pick this out. If you were doing, a typical retro job or just commissioning, you might test those machines and look at them, or you might be out on site when 2, 3, or 4 is operating, and you don't really get that look at a profile for a whole summer like you would here in this case. So we saw, low load conditions, we saw peak conditions, and then we're able to look at this and graph it out and find an energy opportunity. This one here is an example of a failed chilled water valve. So the red line is our preheat temperature, and that blue line is our discharge air temperature. You'll see that the discharge temp is way low. It's at a little bit above 50 degrees. And we can tell that this was leaking by because the chilled water valve was at 0% open. Our preheat temperature is extremely high because our preheat valve actually opened up to try to compensate for the leaking chilled water side. So we ended up with 110 degrees or so off of that preheat coil just to get our discharge to be in the 50s. Actual set point, you'll see whenever they fixed that valve, dropped way down, and we were discharging closer towards 55 to 60 degrees now, and we weren't doing all that preheat. And then for extra credit, you'll see there's one more thing we could flag here, and that's depending on time of year, but we are in January based on the data. The economizer in this case also might be an issue. As this preheat temp should be as close to this discharge as possible. We have cold weather outside. So not only do we have a leaking valve that was causing some additional preheat, we also weren't optimizing our outside air in this case. Looking at this, from a BAS side, if discharge temperature wasn't low enough, they may never have gotten a flag or that this was an issue. And you would think that everything's operating fine. Everyone's comfortable in a space. You're getting a discharge air temperature over 50 degrees. It's not too low where you're freezing somebody out. But, again, you're doing a lot of this behind the scenes that analytics might catch over, just looking at the BAS or typical operation with alarms from that. This next one, an operational tuning example. So you'll see we have kind of the chill water valve position in the blue, and then we have a hot water or preheat valve position in the red. And we get some instances here where both are opening up at the same time, or they're cycling between the two of them. And basically this was occurring because we had a preheat temperature set point that was put in place. So we always had to have that inlet equal to that preheat temp. So as our outside air temperature adjusted, that heating valve would only look at that. But we also had a separate discharge air temperature set point, and that's what our cooling valve was looking at. So these weren't really working in unison the way we would expect. So making adjustments to that, you basically would get one valve at a time. We either want to be heating or we want to be cooling. I will note that this is preheat. We weren't looking at dehumidification in this instance. example of performance analysis and scoring. So this is tracking, basically ranking things on how they operate, whether it be over time and then also compared to each other. So this is a good one. This is space temperature basically versus set point for a bunch of VAV and fan powered boxes that serve different, tenant spaces or, offices in a building. So one way to rank this is over time. So we see, between 7 a.m. and 8 a.m., we're red, and then it starts to turn yellow, and then we get green in the middle of the day. So, this box, for example, takes a little bit of time to get from overnight to get into an ideal temperature condition. So maybe it needs to come on earlier. And then you'll see in the upper left a bunch of different boxes and how they scored compared to each other. So now we know which boxes really give us problems. So, the one that we have highlighted is this FBB13. It's actually a good box. You'll see it has some issues throughout the day, but overall controls pretty well. So that means that these other ones that are yellow would be ones to focus on that might have more problems maintaining space temp. And hopefully other analytics would catch why that is the case, but this is also a quick, easy way to show a building engineer or a customer, hey, these are your ones that could be potential problem areas. We should focus on these first. If you guys have, an overnight shift or you have some free time, which we know time is limited supply, but focus on these boxes first. And, that's where we have the most problems. And then this last one here, there's 2 slides for it, but it was a backwards hot water valve. So basically when we were telling it, the BS was telling it to be closed, it was actually open. And when it was telling it to be opened, it was actually closed. So what happened in the middle of cold weather was the space got cold. The box wanted to heat, and so the space got hot and wanted to cool. So the box shut the hot water valve, which it would, but that actually drove it open and caused it to get too hot. So our discharge temperature, you'll see, is upwards of 100 degrees. Our zone temp, which is the gray line, is above our set point. So an analytic example for this would be looking at that hot water valve position. It's at 0. My discharge is much higher than what I'm getting off the air handler. So something's wrong with that. The valve, it could be leaking through. It could be reversed in this case. There's some potential problem. What was funny about this is what happened too is now the box is going through its typical cooling sequence. So not only did it shut the valve, which actually opened it up, but then it also raises our airflow set point to full cooling mode to try to drive that temperature down. So we end up actually heating more air in a system because of all these issues. If you just looked at this box really quick and the temperature was close and we didn't catch it early enough, you would see again, this box looks like it's in cooling mode. It's doing what it's supposed to do, but it's actually, again, with the backwards valve, you're getting a very hot DAT temperature and the zone temp is continuing to rise. So there's a few examples. I left us with 15 minutes or so here for Q&A. So I don't know how many questions came through. I haven't really been looking at it, but my contact information is on here as well. So if you have something that you want more information on or additional examples for any of our questions, you're also welcome to email me. I'm happy to talk past this presentation as well. But at this point, I guess we can hit the Q&A up. So I see the information on the Big Shy organization. I can dig that up. I don't know, Yvette, is there like a email list or something I can get afterwards? I could follow up to with everybody and put that in there. Cybersecurity measures. So a lot of these software companies and the devices you put on the site, they have a lot of that built in. But the device we use, for example, it talks out to the Amazon cloud and it has outbound traffic only. So it uses specific IT ports and IP addresses to access the cloud in this case. So it's very secure in that case. We work with IT departments. We've gone through comprehensive reviews with a lot of building ITs, et cetera. So in that case, you know, a lot of that's built in with that outbound traffic only, and then using those specific ports so it can only access certain areas of that network. Again, each software company is going to be a little bit different, but that's what we've seen for the vast majority of these, is again, that outbound only traffic, specific ports, specific IP addresses, and then it goes to a cloud. And in our case, it's Amazon, and they're a very large company, and they take on the liability of the security of that. So that data should be secure and safe. Next question, let's see here. How much time do we allocate to integrate a device and software, and then predicting the number of custom analytics? Typically what we see getting a site online, it's going to vary based on the amount of equipment, but we're looking at probably around 1 to 3 months when you start, you know, talking with IT to getting the device out there and talking, and then scanning everything in and then setting up analytics. From the custom side, a lot of that's going to be based on what you have in the building. So like a fan power box or a VAV box, that's very standard across almost every building. Analytics should apply to almost all of that. Where you start getting into the custom stuff is when you run into different situations with maybe, you know, air handling units, or, you know, a chiller plant or a boiler plant, or something that's a little more unique to a building itself. There's a lot of difference between a makeup air unit, you know, an air handler itself, and then like a multi-zone or a hot deck, cold deck style unit. You might have a built-up air handler with, you know, a fan wall in one place, but only one single package unit in another. So sometimes that stuff needs to get customized a little bit more. And then the next thing would be too, when we run those analytics the first time, you're going to get a bunch of flags and issues. And then depending on if you have bad data or other problems with that network or the setup, you might have to tweak and refine a lot of those analytics just for that specific building to kind of dial them in more. Software packages that I recommend. So we use, I'm not going to give the exact name of it, but we use what I would consider to be a glorified, it's like a trend collector or a BACnet sniffer. And what we do is a lot of our stuff is customized in Excel itself. So we run a lot of macros outside of our software, and we just basically export our data, whether it be monthly, weekly, or however we want to look at it. And then we do it in Excel that way, and we map all our points. There's tons of software out there. I could name drop a bunch. I don't know if I'm allowed to do that on an ASHRAE presentation or not. I don't give favoritism to any of them, but they're all different. They all have different capabilities. A lot of them are web-based now too, where you log in through like a Google Chrome, and you have all your sites there, and you can set up analytics across all of them. The difference between, you know, using Excel and just trend logs, and a lot of that you can use as a web API too. You can put that back into an analytics software as well. But a lot of times there's manually, you need to do that with Excel or trend log gathering. And then also if you set up trend logs out of BAS itself, it puts a lot of pressure on that network and a lot of data on that network itself. Whereas with MBCx, a lot of that's done in the software in the cloud separate. And it doesn't bog down the network that's out at the building. Next question is lighting controls at the BAS. So it comes and goes. It depends on the building, but you see a lot of the what's the new control system now? I'm blanking on the name now, but if it's on the BACnet side, basically you can see it. A Lutron system, excuse me. Yeah, so like there's all their control systems for lighting. As long as it can talk BACnet and has the card, you can pick up lighting in that regard. Local sensors, switches, occupancy switches, a lot of that stuff you may not see unless it's tied into some other different network, basically network system. But then that network system also has to be on the BACnet side. So again, like I know Lutron, like that speaks BACnet. You throw a card in, and it speaks on the BACnet area. It's on that network. You know, you can scan it, you can bring it in, you see the points that Lutron would see. Lighting, you know, it's not a ton of opportunity all the time now, because for the most part, control systems with lighting have been pretty good, and we're running a lot of LEDs in most buildings now that would have an advanced network like that. But you know, every once in a while there are some opportunities. Jerry's question here, in my examples, how much was automated analytics versus manual examination? A lot of it for us is a combination. So We set up our analytics kind of just to point us in the right direction and get us moving that way. So it'll flag things like leaking valves and poor control, more than just an alarm like failed damper, whatever it may be. But then I always like to go and look it over anyway and make sure that it's correct. Again, there's a lot of problems with networks having bad trend data, calibration issues, whatever it may be. We're also looking at trends a lot of times, or this analytic data. It could be 15-minute intervals or longer, depending on the network and how fast it is and it can respond. Some of the analytics we set up can be instantaneous as well, but I still like to cross-reference it and look back manually just to make sure that the data that I'm seeing and was flagged correctly and not a false flag. So overcoming hurdles with, I guess, selling the benefits to owners. Thankfully in Chicagoland, we have the rebate utility programs available, which help a lot with that upfront cost. So there's a lot of time just basically with not only the software costs and hardware costs that you have to put on a site to get that data out. And then you have the time to basically scan all these networks and set up all the analytics. So typically what we see is like that study and setup part. A lot of that can get covered through the utility rebate portion or significantly take a chunk out of it. We're lucky here. In other areas of the country, we don't have as much of that luxury. So really, it comes down to payback and what we can look at, from that regard, how much energy a place uses, how much equipment they have out there. Do they have a lot of maintenance problems, or are they understaffed? Is there other reasons to do this besides just energy savings? But I mean, there are other benefits, obviously. Chicago, we don't have as much of a hurdle because we do have a great utility program. If I'm trying to put this in a building, that's smaller, that doesn't really consume a lot of energy in the middle of nowhere, that doesn't have a utility program, it might not be as easy to do. There's obviously a cost benefit to everything, but really we're looking at how much energy can we save? Is there a maintenance benefit to this? Is there a reason to do it just beyond maybe that simple payback number? I guess I could, there's multiple questions on this now, but MBCx softwares or platforms, there's tons of them. The ones that people mostly know, Spark, Tree. We use Connect is what we use, but then we do a lot of our stuff in Excel. There's a ton out there. There's tons of lists. And then, next question on here too even says like other players in the market, SkySpark. Yeah, SkySpark kind of sells that interface. They have a bunch of packaged analytics already, but then they also go ahead and customize. You can do that yourself in there. Like I talked about earlier, we kind of customize all of ours, not only for specific buildings, but then also we built up a ton of it and then just an Excel macro that we apply to all of our sites as well. And we made our own basically point mapping as well as part of our analytics outside of what we use out on site and as an analytics software. Who can get this output? It can really go to anybody. So a lot of the softwares that are out there, they have different logins where you can access a lot of these. For us, we do a lot of customer facing reports. We can do automatic emails. If something would flag in our analytics, that can go directly to a customer. But a lot of times, the building operations staff, they get their building alarms. They're overwhelmed as it is. We typically like to, get all that information and flags ourselves, comb through it, make sure it truly is an error or not a false flag, and then we present it to them, at that time. Some of the top challenges of successfully completing integration of the software, again, IT hurdles the biggest, but then a lot of slow networks or sloppy networks. So if you get a lot of stuff that's not nice on the BACnet side, specifically points being named properly, you could end up with a lot of bad data. So if I scan a site and I get a bunch of fan power boxes and I scan those, and instead of seeing room temp and discharge temp and damper position, I just see analog values or binary values. I then have to go to the BAS front end and hover over each point, see what those values are, and then map them properly on my end and rename them. So it's pretty tough in that regard if you have a network that wasn't really set up on the BACnet side. Is there consideration for process equipment optimization? So what we've dealt with buildings, again, it's on the BACnet side. So if there's some sort of network that talks and communicates with that process equipment, by all means, yes, it could be done with that. If we're talking about like compressed air or like processed chill water or pumps, anything like that, then yes, I mean, a lot of that stuff does have BACnet capability, or it can be, either data logged or some other way. Actual individual process equipment, a lot of times those are standalone machines. They're not really controlled on a network. They have local controls. So it'd be a little bit trickier to really undertake an MBCx process on that. Not to say it can't be done. I know there's actually some process specific companies out there. I don't know the names off the top of my head. I could get that for you guys, but that actually they will install stuff, their own equipment and hardware onto an actual process line, a piece of equipment, and then they'll do something similar to what we do with buildings. Next question was, what level of training for building operators is necessary for MBCx? And then since operators have to navigate the front end and then fix issues, who trains? So it really comes down to if you want to do that in-house, I guess, with a building engineer or a personnel, or use another company. But like what we're trying to do basically is with all these analytics, it kind of gives the information that you need to point you in the right direction. So we're running a lot of stuff that's going to flag, whether it be a VAV damper problem or a temperature sensor problem or a valve or anything to make it where, hey, this is where you should focus for repairing this piece of equipment. Again, we try to make a lot of our stuff a customer facing report where we clean up all the analytic flags that we see and then kind of spot check the data and make sure it was accurate. But really, training wise, if you're familiar with, a building and how it should be operating and engineering, really interpreting it, we try to make it as customer friendly as possible. I could actually share one of our example reports real quick. I'll try to bring it up. Not a Zoom effort, but I use Microsoft Teams, so this is tough for me. Let me see if I can figure this out. All right. I don't know if this worked here. What screen I'm sharing actually at this point. Let me try one more time. Hang on. Does everyone see the PDF up there?
I don't think I can see the PDF.
No? All right. Hang on one second. How about now? No.
No. Can anyone else? Let me see the chat real quick. No.
Huh.
Very weird.
Any luck?
No luck.
Okay. Well, whoever asked that question, I think it was anonymous, but I can actually, I'll email you guys an example report, clip it if you want to see it. If you take down my email, which hopefully is now sharing, I have no idea. I'd be happy to respond to that one offline here. Let's see, do O&M organizations need to change rules and procedures to leverage it? So, depending on, I guess, where the building is and all of that, but what we've seen, is again, through utility rebates, you can kind of get this up and running fairly early on. And then at minimal cost, at least to an organization. And then we kind of work with building engineers and property managers, ownership, O&M, whatever it may be, to kind of get this as a process thing. So it's another tool basically to use. you know, building engineers do rounds, let's say, and they check everything. They may have a maintenance procedure in place. This is just a step above that, where we're really looking for flags and issues beyond just an alarm at the BAS. I guess it really just depends on what you're looking to do, but you know, there's certain things you could put in place, custom analytics that would really, you know, you could do it specifically for a building or an organization or anyone. It's certainly, to me, you know, it's beneficial to leverage if you have the right fit for it. How open are customers to get involved early? And then is the sales cycle longer than commissioning or retro commissioning? So actually currently now in the design process, buildings that are going for like LEED or WELL, there is like a monitoring type credit that's offered in this case, above and beyond just the commissioning cycle. When looking at retro or MBCx, I mean, to me, they're similar programs. It's just MBCx is obviously more comprehensive. It lasts longer, and then you need to have the right facility and BAS and network capabilities to handle it. So it is definitely a longer sales cycle because you're just dealing with someone over the course of a year to 18 months or possibly even longer into the future. But, you know, to us, you know, a lot of the customers that we deal with want to do this. They want to be involved. They're looking for ways to improve operation, save energy, and then also, you know, take a little bit of a load off of, you know, their maintenance and engineering staff that they have in-house at a building, just by helping them out with, you know, some of the reporting and flags and analytics and maintenance items that we come up with. And that looks like most of the questions. So I know some of them I couldn't get to, but again, if you email me separately, I would be happy to share more with what I'm capable of sharing. I know it's tough to do a lot of these on the fly, but I certainly am happy to do, you know, share as much information as I can.
Yeah, Dan, I wanted to thank you again on behalf of Illinois ASHRAE for presenting for us today. And then just a reminder, we have an ASHRAE meeting in April in person. Feel free to join that. And for those looking for PDH credits, you will be emailed shortly after. Thanks, everyone.
All right.